Hi everyone. Today I'm going to remind you how to add and subtract fractions. So I'm going to start with an example. 2/3 plus 3/5 equals. So how do we add these two fractions? If you're thinking of them as regular words, you can write this as 2/3, as I was reading it, plus 3/5. If you make a parallel between these words and whatever we've learned since we were in grade 1, you can think of this as some other words, not necessarily thirds and fifths. Let's say thrones. I couldn't find anything else that started with TH. Plus 3 figures. What is the answer here? Well, nobody knows because why? Because they're not the same. We cannot add things that are not the same. Thrones and figures are not the same things. But see how long it took me to write the thrones and figures? So even easier, I can just write 2T as in thrones plus 3F as in figures. So if you're thinking these are words, we can say the same thing. We cannot add them because they're not the same. Well, later on in algebra, in fact, you're going to learn that, in fact, these cannot be added because they're not the same, obviously, because they're not like terms. So, not like terms. If we want to continue, let's get back to our initial example, 2/3 and 3/5. They cannot be added because they are not the same. Not the same. Same thing for the throne part. So if we get back to our initial example, 2/3 plus 3/5. We discussed that we cannot add them because they're not the same. What makes them be not the same? The denominators, right? So to make them be the same, we have to have the same denominator. Unlike words that cannot be replaced by synonyms, it will make it 2 chairs plus 3 faces, the same things. So we're not going to be able to add them. But unlike that, in math, we can find the same denominator by replacing each of these two fractions by an equivalent fraction. How do we find equivalent fractions? So to just remind you, we can multiply both the numerator and the denominator by the same number, or we can divide both the numerator and the denominator by the same number. But given the fact that there are so many equivalent fractions for each one of them, which one do we choose? We're going to choose, obviously, the one that will have the same denominator. How do we find the same denominator, the common denominator? By finding the lowest common multiple of the denominators. Now, how do we find the lowest common multiple? Lowest common multiple of the denominators? We can do it mentally if you have low numbers, or by using pencil and paper method for larger numbers. Here's the main idea. Think of what a multiple is. For example, how do we find the multiples of 3? So multiples of 3, how do we find them? Can you tell me? So it's 3, 6, 9, 12, 15, and so on, right? You find them by multiplying, because they are multiples, multiplying, okay? We multiply what? So let's look at the 3. We multiply 3 by 1, and here is 3 by 2, and then here is 3 by 3, and 3 by 4, and so on. So you find the multiples of 3 by multiplying 3 by another number. So 3 itself, look at it, 3 itself is found in any of these multiples. So it's 3 times something. Okay, so you can find 3 in the multiples. 24, for example, is a multiple of 3 because 3 is in there. It's, you can see 3 times 8. Okay, so 3 is in here. Keeping this in mind, if you have to compute the common multiple of some numbers, you have to have each multiple in there. You can, so if I want to find the multiple of, I don't know, 6 and 8, I have to be able to recognize the 6 and the 8 in that number, in that common multiple. In saying this, some people might understand, oh, the common multiple is 8 times 6, because I have to recognize, to see both 8 and 6 in there. So the multiple is 48. Yeah, it's a common multiple, but it's not the lowest one. Why do we need the lowest one? Because we don't like large numbers. Okay, so let's see. Let's check how this works. We're talking about the lowest common multiple of 6 and 8. Lowest common multiple of 6 and 8. And we said that it might be 48 because we can find 6 times 8. But let's see. Multiples of 6 equals. So 6 times 1 is 6. 6 times 2, 12. Times 3, 18. 6 times 4. Okay, so I'm going by 6 is 24. 30, 36, 42, 48, 54, 60, 66, and so on. Multiples of 8 equals 8 times 1, 8 times 2, 16, 24, 8 times 3, 8 times 4, 8 times 5, times 6, times 7, 56, and so on. As you can see, you can find a lot of common multiples. 24 is in both. Oh, I'm sorry. 24 is in both. 48 is in both. Next one would be 72, and so on. All of them are common multiples. But which one would you like to work with? 48? No, I'd like to work with 24. Why? Because it's the lowest and makes computation easier, at least for me. If you like working with large numbers, feel free to use any of them, but don't complain it's too difficult. Extra question: which number out of 6 and 8 got to the LCM the fastest? Why? Answer: 8, because it's larger. So if you have a visual aid here, look at that. So start at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25. So that would be the 24. So the 6 goes like that. 6, 7, 8, 9, 10, 11, 12, 13, 12. So 6 goes to 12. And then 2, 18, 13, 14, 15, 16, 17, 18. And then 2, 24. While 8 goes 8, 2, 16, 12, 13, 14, 15, 16, and then 2, 24. Only 2 steps for 8. So if you want to compute the lowest common multiple mentally fast, you look at the largest of the numbers because it gets to the lowest multiple faster. So from 8 to 24, 2 steps. While here, 1, 2, 3 steps. So now let's get to solve a question. 5 over 6 plus 3 over 8. Can we add the two fractions? No. Why? They don't have the same denominator. Okay, that's 5 6 plus 3 8, not the same things. How do we get it? Because these ones are smaller numbers like 6 and 8. We can find them the same way I told you. Look at the largest of the denominators, which in our case is 8. Is 8 a multiple of 6? No. So the next multiple of 8 is 16. Is 16 a multiple of 6? No. What's the next multiple of 8? 24. Is 24 a multiple of 6? Yes. Finally, 24 is a multiple of 8 and the 6, so that's the lowest common multiple. How do we write the equivalent fractions? So I'm going to multiply both the numerator and the denominator by what number to get a 24 here? By 4, right? I'm going to show it here. By what number am I going to multiply them both to get the 24 here? By 3. So 4 times 5, 20. 4 over 4 times 6, 24. Plus 3 times 3, 9. Over 3 times 8, 24. Equals, keep the same denominator, because if it's 3 apples plus 5 apples, it's still 8 apples. It's not 8 apples squared or 8, I don't know, pairs. So it's still 24. 29 over 24. Don't forget, your final answer, you have to do two things. To try to simplify it if it's possible, and to write it as an improper or a mixed number if it's an improper fraction. So in this case, I cannot simplify it, but I can write it as a mixed number, 1 and 5 over 24. Okay, so our final answer. And now that we solve this question, how do we deal with larger denominators? Because not all the time we're going to be that lucky to have small denominators. As in, for example, 9 over 56 minus 5 over 240. Yeah, you could use the same method as I told you. Look at the largest of the denominators, 240. Is it a multiple of 56? No, not really. If it takes you longer than 10 seconds to find the common denominator, just use the pen and paper method. So I won't even go there. So the next multiple of 240 is 480. I have no idea if 56, I have no idea that fast if 56 goes into 480. So I'm going to proceed with using the other method. So how do we do it? Well, we cannot compute them because the denominators are quite large, right? So let's break them. How do we break them? Well, obviously we cannot simplify because that's the way I chose the numbers. We can break them by using prime factorization. So the first step when dealing with these large numbers, do the prime factorization of your denominators. Okay. And to continue explaining this to you, I'm going to choose an algebraic example because it's going to be way easier to understand it. So here is an example similar to our example. So instead of having numbers, I'm going to just place the letters. So for example, 1 over a to the 3, c to the 2, h to the 2, plus 2 over a squared d g h to the 3 w to the 2 minus 3 over h to the 5 s to the 2 w to the 4. Usually the letters, when you have algebraic expressions, the letters are in alphabetical order. But in here, you can see I chose some weird letters instead of A, B, C, D, E, F, G. Because I want to look at this situation in a different way. Let's say you have your own business, construction business, where you need to use some tools. Each day, various tools that you need. You go to Home Depot to buy what you need, and of course you can buy the whole thing in Home Depot, but do you have the money? Do you want to spend that much money? I don't think so. Let's read this example this way. For example, day 1, you need 3 Allen keys, 2 clamps, 2 hammers. Day 2, you're going to need 2 Allen keys, 1 drill, 1 goggle, 3 hammers, 2 wrenches. And day 3, you need 5 hammers, you make it up, 2 screwdrivers, and 4 wrenches. What are you gonna buy from Home Depot? You have to be covered for every single day. But remember, once you use the tools the first day, you're not gonna throw them. You can reuse them the next day. Okay? So let's see what you're gonna buy. That's gonna be our lowest common multiple. So obviously, what are the tools that we need? First of all, we look at the tools that we need, and then we're gonna look at the number. So we need Allen keys. See here? We need clamps. You need hammers. What else do we need? Allen keys are on the list. Drills. Goggles. Hammers, I wrote them already. Wrenches. Hammers, I wrote them. Screwdrivers and wrenches, I wrote them. So how many do you need? The lowest number of Allen keys that will make you be covered every single day. Don't tell me you need 3 here and 2 here. That means you need 5. No, because if you buy whatever, you can reuse them, as I was telling you. So can I buy, what's the minimum? I could buy 2, but then I won't be covered here where I need 3. If I buy 3, out of these 3, I can reuse 2 tomorrow. So 3 is fine. Okay. How many clamps do we need? Only 2 here, so I don't have anything here. So 2 clamps. How many hammers? Let's see. I need 2 the first day, 3 the second day, and 5 here. Do I need to buy 10 of them? 2 here, 3, 5, plus 5, 10? No. How many? Right, 5. Because if I have 5 hammers, I can use out of those 5, I can use 2 of them here. I bring them back home. Next day I can use 3 out of the 5s that I have. And then the last day I can use 5 of them. How many drills? 1, right? I don't have to write anything. How many goggles? 1, because I only need 1 here. How many wrenches? 4, right? How many screwdrivers? So I need only 2 here, so 2. That's the lowest common denominator that I have. And how do you find what you need to multiply this by in order to make fractions that have the same denominator, this denominator? Well, you just write here the tools that you left home. So this is my toolbox, okay? How many of them? Well, not my toolbox, whatever tools I have at home in my garage. So I took all the Allen keys with me. I don't have any home. I took all of the clamps. I don't have any with me. So out of the 5 hammers, I took 2. So I left home 3. Okay. I left home the drill, the goggle, the wrenches, and the screwdriver. So D, G, W to the 4, S to the 2. Here, what did I leave home? So out of the 3 Allen keys, I took 2 with me. I have 1 left at home. How many clamps? I didn't take any, so at home I have C2. How many hammers? So out of the 5, I took 3. I left home 2. How many drills? I took them all. I took the goggles. The wrenches out of 4, I took 2, so W to the 2. 2 of them are left home, and the screwdrivers are left home. Same thing here. You complete it and you let me know. That's it. Okay? This requires a lot of attention. That's why, in order to make things easier for us, letters should be written in alphabetical order, while numbers, you write them in ascending order. So let's get back to our example. 9 over 56, I'm going to just copy it, and minus 5 over 240. So, prime factorization of 56. 56 is divisible by 2, 28. Divisible by 2, 14. Divisible by 2, 7 is the prime number 7. 240 is divisible by 10. So 10 is 2 times 5. So when you divide it by 10, you get 24. 24 is divisible by 2, 12. Divisible by 2, 6. Divisible by 2, 3. And 3 is a prime number. So 56, I can write it again. 9 over, instead of 56, I can write 2 to the power of 1, 2, 3 times 7 minus 5 over 240 is 2, 1, 2, 3, 4, 2 to the 4 times 3 times 5. Oh, okay, I can simplify here by 5. But for the sake of our computations, let's not simplify. Maybe I should have written 51 here. Okay. So, what's the common denominator? The same thing. Let's look at the tools that we need. We need a 2, we need 2s, we need 7s, we need 3s, and we need 5s. As I was saying, in ascending order, that would be 2, 3, 5, 7, because it's easier to follow. How many 2s do we need? We need 3 here, we need 4 here. To be covered for all of them, we need 4, the maximum of them. How many 3s? Only 1 here. How many 5s? Only 1. How many 7s? Only 1. Okay, that's the common denominator. What do I multiply this by? So what's left at home? I took only 3 2s, so I need 1 2. I need a 3 and a 5. Here, I need, so I took the 2, all of the 2s, all of the 3s, all of the 5s, I need 1 7. equals. So what number is this? 2 times 3 times 5. I can do it 5 times 2, 10 times 3, 30. And then I need to multiply it by 9, which is 270. The same thing, 30 times this denominator is going to give me this denominator. Minus 7 times 51, 357. Okay. And now you just add, subtract. And here, obviously, 270 minus 357 is going to be a negative difference. That's negative 87 over this big denominator. If you want to compute it, fine, but I would just leave it this way. Why? Because what's the next step here? It would be to simplify. So these are the prime factors, and try to see if 87 is divisible by any of them. Is 87 divisible by 2? No. By 3, 8 times 7, 8 plus 7, 15. Perfect, so I can divide it by 3. So equals minus 87 divided by 3 is 29 over 2 to the 4 times 5 times 7. 29 is a prime number, so I won't bother checking if it's still, if we can still simplify it. So now that's the question. This is the way we add and subtract fractions. I'm going to get back to you with how to subtract fractions, or let's do it now. How to subtract fractions where you need to borrow. For example, 7 1/5 minus 2 3/4. Okay, so the same thing, the common denominator is 20, the largest of the denominator is 5, not a multiple of 4, 10, not a multiple of 4, 15, not a multiple of 4, 20 is a multiple of 4, so that's the common denominator. So if you multiply here by 4 to get the denominator 20, and here by 5, you can see that you have 7 and 4 times 1, 4, 4 times 5, 20, minus 2 wholes and 5 times 3, 15 over 5 times 4, 20. And it would be possible to subtract 7 minus 2, which is 5, but keep the denominator, but you won't be able to subtract 4 and 15. You have to do this in your mind eventually. Okay, let's continue from here. So because I cannot do this subtraction, I have to borrow. So I'm going to borrow 1 from here. That will make it 6. And 1 and 4 over 20. Okay. The 1 and 4 over 20, I'm going to turn it into an improper fraction. So 6 and 1, that makes it 7. So 6 and 1 times 20, 20 plus the 4, 24 over 20. Sorry, I should have, okay. Minus 2 and 15 over 20, which equals, now I can subtract everything. 6 minus 2 is 4. 24 minus 15, 9 over 20. Can I simplify any further? No. So this is our final answer, and I hope you enjoyed the lesson. See you next time. Have fun with your handout, okay?